Next question, that is analyze the range of k for a closed loop transfer function given this k divided by s into s plus 2 into s square plus s plus 1 plus k is stable using RH criteria, and also they have given for what value of k the system oscillates and what is the corresponding frequency of oscillation. Okay, so we need to be finding the range of k, the marginal value of k, that is for what value of k they have asked, so we need to finding the marginal value as well as the corresponding frequency of oscillations. Okay, so yeah, let's try to solve this. Okay, so first given, write the transfer function c of s by r of s, that is k by s into s plus 2 into s square plus s plus 1 into plus k, so that's equal to k by, multiply this, so s square plus 2s into s square plus s plus 1 plus k. Okay, that is k by, so multiply 1 by 1, that is s square, s square into s square is s power 4, s square into s is s cube, s square into 1 is s square, plus 2s cube, 2s into s square is 2s cube, plus 2s square plus 2s plus k. So therefore our final transfer function which we are getting is k divided by s power 4 plus s cube and 2s cube, so plus 3s cube plus s square and 2s square is 3s square plus 2s plus k. Okay, so this, from this way, after simplifying this term, we have got one simple transfer function. So now using this transfer function, write the characteristic equation, that is we know that characteristic equation always the denominator of transfer function, that is s power 4 plus 3s cube plus 3s square plus 2s plus k equal to 0. Yeah, so this is the transfer function. So now for this transfer function, apply the Raoult array. Okay, so apply the Raoult array, start writing the Raoult array now, starting from s power 4 s cube s square up to s power 0. So first write the coefficient of s power 4, that is 1, skip one term, that is write the coefficient of s square, that is 3, skip one term, and the coefficient of s power 0 is k. Okay, then for coefficient of s cube is 3, skip one term, coefficient of s is 2, skip one term, since no term so it is 0 again. So using these two rows, calculate the coefficients of s square now, that is 3 into 3 minus 1 into 2, 3 3s are 9, minus 1 2s are 2 by 3, that is 9 minus 2 by 3, that's equal to 7 by 3. So here we need to be writing 7 by 3. Okay, and here 3 into k, that is 3k, and 1 into 0 is 0 by 3, so that is 3k by 3. So here we are getting k, so here write it as k. Again here it is 0, since we don't have any term, so it is 0. So 7 by 3, so calculate the next row elements, that is 7 by 3 into 2 minus 3k divided by 7 by 3, that is 14 minus 9k by 7. Okay, so this 3 and 3 would be getting cancelled after taking the LCM, right? So we are getting 14 minus 9k by 7 here. Okay, and here this term is again 0, and again if we multiply this term into this term, minus 7 by 3 into 0, since 7 by 3 into 0 is 0, divided by the same denominator, this one, right? So we can cancel denominator along with this term in the numerator, so you would be left with only k, so that's why I've written it as k. Okay, so now we have written the Raoult array. So now firstly let's find the range of k. In order to find the marginal value of k, first consider this last element, that is we know that one condition we have seen, right? This s power 0 last term, whenever we get k, it should always be equal, it should always be greater than 0, right? And also for marginal value of k, there must be one row of zeros, right? For that k is equal to k margin. So first find the range of k. So k, consider this upper row, that is 14 minus 9k by 7 is also greater than 0. So 14 minus 9k, if you take this 0 to other side, it is again 0. So 14 is greater than 9k. If you bring this minus 9k to that side, it is 14 is greater than 9k. So 14 by 9 is greater than k. So therefore 14 by 9 is 1.55 is greater than k. Okay, so we got one condition that 1.55 is greater than k. So we can say that the range of k lies between 0 to 1.55. Okay, since here 1.55 is greater than k. Okay, so we can say that if 1.55 is greater than k, so we can say that k should be less than 1.55. So therefore this is the range of k which we have obtained, that is k lies between 0 to 1.55. So now for k is equal to k margin, we would be getting one marginal value, right? That is for k equal to k MAR, what we would be getting? 14 minus 9k k, we have taken k, right? Since k equal to k margin, so 14 minus 9 k margin divided by 7. So instead of greater than 0, we need to be equating it to 0. So because we know that whenever we want to obtain any marginal value, we know that we must have a row of zeros, right? But in this row array, we have this term here for k is equal to k margin. Okay, if we equate this whole term to 0, so this would be one row of 0, right? So that's why I have written 14 minus 9 k margin by 7 equal to 0. So now using this equation, you can solve for k margin, that is 14 minus 9 k margin. If you bring this 7 to other side, that is again 0. 0 into 7 is 0. So 14 is equal to 9 into k margin. So therefore k margin answer which you are getting is again 14 by 9, that is k margin is equal to 1.55. so this is the marginal value of k. For this value of k, the system would oscillate. So therefore we can write, therefore system oscillates at k equal to 1.55. Also they have also told us to find the corresponding frequency of oscillation. Okay, for that what we need to be doing is, since we have a row of zeros, because k margin we have equated to 0, first so now consider the auxiliary equation above this row of 0, that is 7 by 3 s square plus k, that is 7 by auxiliary equation 7 by 3 s square plus k, where k equal to k margin, right? So write directly k margin equal to 0. Now 7 by 3, if we solve it, is 2.33 s square plus k margin, just now we have got it as 1.55 equal to 0. So now solve this equation to get the answer for in terms of s, that is 2.33 s square is equal to minus 1.55. So s square is equal to minus 1.55 divided by 2.33. S square we would be getting it as, if we solve this, we would be getting as minus 0.665. Therefore s is equal to plus or minus square root of minus 0.665. So s is equal to plus or minus, since we have a minus here, so we would be having one imaginary term j or I, both are same, and the square root of 0.665 is 0.815. so this is the answer which we get for j. Since this is of the form of s is equal to plus or minus j omega, right? If we compare this equation with this equation, so in place of j, this is the value of omega, that is omega. So omega answer which you are getting is 0.815 radians per second. Okay, so this is the value of omega here which we've got. In place of omega we have 0.815, right? So this is the corresponding frequency of oscillation which we are getting for this question. So that's all this question. Yeah, so this is the question. Sketch the root locus plot for the given characteristic equation. Okay, so in this case they have not given any transfer function, they have given one equation. That equation we need to be converting into a general transfer function form in order to find the value of g of s into h of s. Okay, then we need to be using the root locus technique. Okay, so here this is the equation obtained. They have given the characteristic equation, that is of the form 1 plus g of s into h of s is equal to 0. We need to be putting this in this form in order to get the value of the transfer function. Okay, so this is the equation given, that is s square plus 2s plus 2 plus k into s plus 4 equal to 0. Okay, so if you observe this equation carefully, what we can say that the general formula of g of s into h of s, how it is represented. It is represented as k into 1 plus t1s divided by s to the power j into 1 plus tas, and it goes on, right? So this, in this way we need to be representing the general transfer function, right? So if you observe this equation carefully, what we can do is we can write it as 1 plus k into s plus 4 divided by s square plus 2s plus 2, where this transfer function is of the form this only, okay, is equal to 0. Okay, if we solve this equation again, we would be getting this same equation. Okay, so that's why we can say that our transfer function g of s into h of s is equal to k into s plus 4 divided by s square plus 2s plus 2. Okay, so using that equation here, so we have found the transfer function like this. Okay, so now again the same steps, solution now begins now. That is step 1. We need to be calculating the number of loci. For that we need to be knowing zeros and poles. So zeros, we have 1 0 here. Poles here, since we have quadratic equation, we will be obtaining two roots, so 2 poles 1 0, so that 0 is s is equal to minus 4, and the poles s is equal to, so we need to be checking that in calculator again. Okay, mode setup equation, it is of the form ax square plus bx plus c, and substitute the coefficient, that is 1 2 and 2, 1 2 2. So this is the first root, that is minus 1 plus I, and the second root is minus 1 minus I. Okay, so now these are the roots obtained. So since here we can see that the roots obtained are complex roots, so that step of calculating the angle of departure, now it exists, now it comes into the picture. So before that only, for that let's try to calculate the asymptotes. Okay, number of asymptotes is equal to number of poles minus number of zeros. So poles are 2 and zeros are 1, so number of asymptotes obtained is 1. Okay, so similarly step 3, angle of asymptote, since we have only one asymptote, so angle of asymptote obtained is also only one single angle, and most of the cases the angle obtained is 180 degree only. Okay, so q value is only 0 now, so that is theta is equal to 2 into 0 plus 1 into 180 degree divided by 2 minus 1 is 1, so it is 180 degree only. So this is the angle of asymptote obtained, 180 degree. So it's not required to draw this angle only, but still centroid calculation, most of the cases, 90% of the cases, whenever we get one asymptote along with that angle 180 degree, it's obvious that the centroid, we must be getting a positive answer only for centroid. But still, let's check it. Summation of real part of poles minus summation of real part of zeros divided by p minus z, so that is equal to real part of poles of, that is minus 1 and minus 1 minus 2 minus real part of 0, that is minus 1, so minus 2, sorry, this pole value is minus 4. Okay, so 0 value is minus 4, so minus 2 minus 1 minus 4 divided by 1, so that is minus 2 plus 4 by 1, the answer is 2, right, plus 2, since sigma obtained is again positive, so that's why no, the centroid doesn't exist. Along with that, the angle of asymptote also will not be existing. Okay, so now let's directly go to the fifth step, that is calculation of breakaway point. So for breakaway point, in the question only they have mentioned that this is the characteristic equation, right, but we need to rearrange some of the terms in order to become into a certain characteristic equation from the higher degree to lower degree. So we need to rearrange that, that is s square plus 2s plus 2 plus multiply this k, that is ks plus 4s is equal to 0. So now what we can see is s square plus, here we have, so this is 4k, okay, 4 into k, 2s and ks, s is common, so 2 plus k we can write it together, s plus 2 plus 4k, both are constant, so we can write it together, 2 plus 4k is equal to 0. Now this is the certain characteristic equation which we have rearranged and obtained. Okay, so now this characteristic equation, we need to be finding the value of k, that is again same, this to take the same equation, that is s square plus 2s plus 2 plus k into s plus 4 is equal to 0. So that is, bring k into s plus 4 to one side, so is equal to minus s square minus 2s minus 2. So our value of k is minus s square minus 2s minus 2 divided by s plus 4. Okay, so this is the value of k. Now we need to be computing the derivative of k with respect to s equal to 0. Again, since this is of the form of u by v, so we need to be using u by v rule, that is denominator square, and in the numerator part first write the numerator as it is, s square minus 2s minus 2 into differentiation of denominator of s plus 4, that is differentiation of s is 1, minus denominator as it is into differentiation of numerator, that is differentiation of minus s square is minus 2s, and differentiation of minus 2s is minus 2. So now again this is equal to 0. So if you multiply this s plus 4 whole square so with 0, so that is 0 again. So minus s square minus 2s minus 2 is equal to, into 1 is equal to this same term, that is minus s square minus 2s minus 2 minus of s plus 4, and again in this case we can take minus common outside and write it as 2s plus 2 equal to 0, minus s square minus 2s minus 2. Again this two terms are getting multiplied, minus into minus is plus, so plus s plus 4 into 2s plus 2 equal to 0. So that is minus s square minus 2s minus 2, and multiply s into 2s is plus 2s square, 2 into s is 2s, plus 4 into 2s is 8s, plus 4 into 2 is 8 equal to 0. So you can cancel minus 2s and plus 2s. Minus s square plus 2s square is again plus s square, plus 8s plus 8 is equal to 0. Okay, so this is the quadratic equation which we have obtained now. So now for this equation we need to be finding the roots, that is again using the same, this is again of the form ax square plus bx plus c. So coefficients are 1, 8 and 8. Substitute that, 1, 8, 8. So the values are minus 1.17, and the second root is minus 6. So we have made one mistake here, that is, if you observe here, it is not directly 8, we have here minus 2, right? I've skipped that, so it happens sometimes. So that is 8 minus 2 is 6, right? So the equation is s square plus 8s plus 6 equal to 0. Okay, so now for this equation try to find the roots, that is the coefficients are 1, 8 and 6. So substitute that one by one, 1, 8, 6. Yeah, so now the roots are minus 0.83 and minus 7.16. okay, so take that correction down, just to observe that it happens sometimes. So this is 6, okay, not 8. So and these are the two roots obtained. So now we need to be checking whether these two roots are valid breakaway point or invalid breakaway point, that is we need to be checking whether these 2 points lie in the part of root locus or not. Okay, so now let's check that by drawing one rough plot. So yeah, the two roots obtained are minus 0.83 and minus 7.16. Minus 0.83 lies here somewhere, okay, and minus 7.16, let me say it lies here somewhere. Okay, so these are the two breakaway points. So now we need to be checking which part is a part of a root locus. That is, if you observe from this 0, whenever you observe from 0 to the right hand side of the graph, from 0 we should be having one root with respect to symmetric to real axis. Okay, whenever we check from 0, whenever from 0 we check in the right hand side, one pole it should be on the real axis only, it should be symmetric to real axis. If there is no pole which is symmetric to real axis, so here in this case from this 0 if you observe, there are two poles but not on the real axis, it's on the surface. Okay, so we can see that there are no poles here, so that's why we can say that the number of poles are 0, and 0 is an even number in general. So that's why this whole surface from 0 to 4 is not a part of root locus. Okay, and from this 0 to infinity this whole thing is a part of root locus. So that's why we can say that this point is invalid, minus 0.83, and the real breakaway point obtained is minus 7.16. so this is the real breakaway point. Okay, so yeah, so now let's continue the problem by calculating the angle of departure. So before angle of departure, let's try to calculate the point of intersection. Okay, after that, while drawing the plot, let's calculate angle of departure. So now this is a characteristic equation. So now let's draw the route array for this. First step, in order to calculate the point of intersection, s square, s power 1, s power 0. The coefficient of s square is 1. Skip this term and write this term, that is 2 plus 4k, and 0. The coefficient of s power 1 is 2 plus k, 0, 0. So now using these two rows, calculate the element in this row, that is 2 plus k into 2 plus 4k minus 0 divided by 2 plus k. So we can see that these two would be getting cancelled. So 2 plus 4k would be coming here. And now for this, what we're doing, 2 plus 4k should be greater than 0, right? So that's why the just above element, that is 2 plus k should be replaced by k margin now, equal to 0, in order to make this as a row of 0. So k margin value we are getting here again as minus 2. Okay, so now this k margin value we need to be substituting in the auxiliary equation by making a of s is equal to 0. Auxiliary equation means just above the row of zeros, that is s square plus 2 plus 4 k margin equal to 0. So s square plus 2 plus 4 into minus 2 equal to 0. S square plus 2 minus 8 is equal to 0. S square minus 6 is equal to 0. 2 minus 8 is minus 6. So s square we are getting it as 6. So s is equal to plus or minus square root of 6. Again we are not getting any imaginary term, we are getting one real term as an answer. So we can directly write it as no point of intersection. Okay, since we are not getting any imaginary term, so that's why we don't have any point of intersection here. So we have left in only one step, that is the calculation of step 6, that is angle of departure, right? So that we will be calculating while we draw the graph. Okay, the formula I'll write and keep it, that is theta d is equal to 180 degree minus summation theta p minus summation theta z. Okay, so now let's see this calculation of angle of departure. First let's draw the plot. So here I've drawn this rough plot. Okay, so now let's mark the poles and zeros first. So the two poles are complex poles, that is one pole is minus 1 plus I, so this will be coming here, and minus 1 minus I, so this will be coming here. Then try to join those two poles. Okay, then we have one more 0 at minus 4. Okay, so this is 1 0 at minus 4. Okay, so now we have one breakaway point, right? With the valid breakaway point is minus 7.16, that comes somewhere around here. Mark that point as breakaway point like this, so highlight it like this. This is the breakaway point. Okay, so now we need to be calculating the angle of departure, right, with respect to these two poles. So now let's name this pole as pole 1 and pole 2. Okay, and this as one z1, that is 1 0 we have, that's why. So now the angle of departure calculation is formula is 180 degree minus summation theta p minus summation theta z. First we need to be calculating summation theta p. So we need to be calculating only one angle, that is theta p2, since we are calculating theta d with respect to p1. Okay, so that's why we need to be calculating the angle of theta p2, which is made with respect to pole 1 and origin. So if we see that this angle made is 90 degree, right, with respect to pole 1 and origin, the angle is 90 degree, so we can directly write it as 90 degree. So summation theta p is equal to 90 degree. So now what about summation theta z? Okay, the angle made by this 0, okay, that is theta z1. We have one formula for that, or either we can have one formula, also we can join this like this with respect to pole 1 and origin, and we can check the angle. So now first let's check that, let's see how much angle we are getting. Okay, from this 0, let's check the angle what we are getting if we join this like this. So let's join this first. Okay, and this angle what we are getting is approximately equal to some 19 or 18 degree. So let's, for the safer side, I'll write it as 18 degree. Okay, in order to cross check this angle, I've told you that we have one formula, that is tan inverse of opposite by adjacent. So that is theta z1 is equal to tan inverse of opposite side, that is from this point the opposite side is this, right? So we can see that from we have one scale here that is from 0 to plus side, so we can say that this is 1 unit divided by adjacent side, that is this is the adjacent side from -1 to -4, so the difference is 3 units, so we can write 1 by 3. Okay, and we can check that in the calculator. That is tan inverse of 1 by 3. See, we are getting approximately equal to 18.4 degree, right? So for the safer side, I've written it as 18 degrees. So exact value of this theta here obtained here is 18.4 degree. Okay. So here in the graph, I've marked it as 18 degree, rounded off. You can mark it if you want exactly. You can mark it 18.4 in order for further calculation. So our summation theta z is equal to 18.4 degree. Okay. So now we got summation theta p as well as summation theta z. So theta d with respect to p1 is equal to 180 degree minus 90 minus 18.4. So that is equal to theta d p1 180 minus 90 minus 18.4 is 71.6. So our angle obtained is 108.4 degree. Okay, that is theta d with respect to p1. So here we are getting an angle of 108 degree, so that's why obviously here with respect to p2 we are getting the mirror image of that, so that's why theta d with respect to p2 is equal to minus 108.4 degree. Okay, so these are the two angles obtained. So now let's plot that angle on pole 1 and pole 2. So one angle is 108.4 degree, it comes somewhere around here, and this is minus 108.4 degree, and join them like this. This is one angle and this is one angle. Okay, so these are the two angles here. One is 108. Okay, so these are the two angles of departure. Okay, so now we need to be drawing the root locus plot. So according to root locus plot, from the pole, from one pole it would be, from here one branch would be touching the breakaway point, and here one branch would be touching the breakaway point. So that is in the angle of 108 degrees. So the plot would be bended like this, and here it would be touching the breakaway point. Okay, same goes with this plot. Here in the angle of 108 degree it would be moving and touching this breakaway point, and so this is one branch. One branch would be moving towards 0, since we have one 0 here, and one branch would be moving towards infinity, right? Minus infinity, since we have one angle, right, of minus 180 degree as a asymptote angle. So that comes into the picture now, and this is the general root locus, rough root locus plot for this problem. Okay.